Hello everyone, welcome to ashatech.com. In this lecture, we are going to discuss programmable logic controllers. And now, we are going to give you a feel of how some PLCs in the field outside there look like, and maybe the several kind of connections that are put alongside those PLCs. So you can see this is typical of a radar system that is installed in the field. This is for a fire control system somewhere. This is for an industrial waste treatment plant. And then this is actually for a wash machine for cars and basically found in car manufacturing industries. So in this discussion, we are going to look at what are the differences between PLCs and controllers, what are the PLCs themselves, the advantages, the components and the functions of different components, and then we will proceed with more content. Now, we want to define what a PLC is. One is that it is an industrial digital computer designed for control and automation of manufacturing processes. These can include the assembly lines, robotic devices, and any activity that requires high reliability, ease of programming, and process fault diagnosis. All those complex systems that you know in the industrial setting, we can apply PLCs so that we can have an efficient and effective control. And now we can say they are used extensively in industrial and commercial applications. Now, there are a number of characteristics. So these are the key features that you'll find with the PLCs. One is that they are rugged and durable, meaning they are designed to withstand harsh industrial environments, and these include extreme temperatures, humidity, vibrations, and electrical noise. They have a modular design, meaning not, of course, we will see that there are different types of PLCs, and one of them is a modular one. So an advantage is that a PLC can be designed with provision for future expansion, and therefore you can expand this with various input and output modules, and therefore be able to introduce in other functions that you want this PLC to play. Now, we find that it is also programmable, but in a way that we use specialized programming languages, and these are the ladder logic, we have the functional block diagrams, we have the instruction list, structured text, and then we know that these are all designed to perform specific control tasks. These PLCs also have real-time operation, meaning they are capable of performing complex tasks in real time with high reliability and precision. Now we have looked at a programmable logic controller, and we want to understand how is it different from other control systems. For example, where we have the microcontroller units. So we know that a microcontroller, to define, is a compact integrated circuit designed to govern a specific operation in an embedded system. Majorly, microcontroller is at the center of a control system, and this majorly consists of integrated circuits, and it is designed to perform a specific task, and usually in embedded systems. It typically includes a processor, a memory, input-output peripherals on a single chip, and we can see they are used in automatically controlled devices and products such as automobile engine control systems, remote controls, office machines, appliances, power tools, to mention a few. Now, the key characteristics or features of microcontroller units is that we have single chip system. So this single chip system is in such a way that it combines both a CPU memory, that is the random access memory, the read-only memory, this EEPROM, and the other peripherals that could include timers, counters, input-output ports, analog to digital converters, digital to analog converters, all in one package. So you can have a CPU, a memory device, you have input outputs, ADC, DSC, all in what? In one package. And that is what comes on a microcontroller. So you also find an embedded use as one of the key characteristics, meaning they are designed to be embedded in a specific application or product for dedicated tasks. For example, you could want to maybe design a control system that works with a music system, that works with maybe an amplifier. So you would design this and embed it in that system that you want to play an amplification function. They are also low power consuming, meaning that they are used in battery powered devices, usually about 12 volts batteries, and lower 5 volts, 3 volts. You find all those low power supply systems can be used in powering the microcontroller units. Programmable, meaning that you can program this microcontroller, and you see this is different from that one of programmable logic controllers, because we can use C, we can use C++, assembly language, to program it so that it can perform specific tasks in embedded systems. It also has versatile applications in a way that we can find it used in a wide range of applications, from simple devices such as toys to household appliances to complex systems like in automotive controls and industrial automation. Now, we want to look at first of all the advantages. Let's look at the advantages of PLCs. So PLCs are reliable and durable. We have already said that they are designed to operate in harsh industrial environments. So where we have extreme temperatures, humidity, dust, vibrations, electrical noise, these PLCs are able to deliver their functions effectively and efficiently. They are also durable, so they have that characteristic of longevity. So we also find that they are flexible and scalable. When you look at the modular design of PLCs is that you have a PLC that is playing a function today, but it has the capacity to expand. There is that possibility of expandability, of expansion. So you find you can either add or remove the input-output modules so that you adapt to different applications. They are also programmable, so that makes them flexible, meaning you can write another program from what it previously was operating on. You reprogram it so that it can now play a function that is in a new application. So the next one is that There is ease of maintenance and troubleshooting with PLCs. We find we have diagnostics and monitoring in PLCs because they have those monitoring tools that make it easier to identify and troubleshoot issues. For example, a PLC will have an HMI, what we call the human machine interface. So, as the process is moving on, wherever there is a problem, because of this monitoring tool, because of this interface, you are able to see and locate where the problem is, and therefore you can easily maintain your system. You can easily repair that particular system because you can easily identify where the problem is. Now we have also them being speed and also being able to operate in a real-time operation. For example, you have sensors bringing data from the field, and then depending on the program of the PLC, it is able to execute a particular function. So you'll find that they are fast in processing that information, but also they are able to do things in a real time. Then standardization and compatibility. You find PLCs are more are compatible to most of the industrial standards, and we find the IEC 61131-3 as one of the most common industrial standards that PLCs adhere to. And this ensures compatibility and interoperability with other devices and systems. And a wide range of protocols for communication, making it easier to integrate these PLCs with other equipment and systems. They also use a user-friendly programming mechanism where you find you can use, ladder logic. You can use function block diagrams. You can use structured text, and these are easy to learn and use to traditional. When you compare these ladder logic, function block diagrams, instruction list, structured text, with the traditional programming of microcontrollers like studying C, C++, assembly language, you find it is a little bit more friendly and easier to learn than those other programming languages for microcontrollers. Then, because of the graphical interfaces, you are able to also see what you're programming, and this is easy because of graphical programming environments. Then safety and security. The built-in safety features make PLCs easier to work with, and of course, making people safe from the high voltages. For example, you have 24 volts are being used to actuate systems of, for example, coils that are connected to a high voltage. And then the PLC side is where you're operating from, where you have low voltage and therefore you are safe. And also, you find it has emergency stops and interlocks whenever there are issues. Also, modern PLCs actually incorporate advanced security features to protect against unauthorized access and cyber threats because in most cases, as you're programming, you need to provide passwords. And these passwords are not usually common to everyone. So someone who is a cyber threat, you will find difficulty in penetrating this PLC because he doesn't have the credentials to log in. Then they are cost effective when you look at it, when you compare them with the other control systems. You have also that PLCs are able to integrate with other automation systems. For example, PLCs can be designed to integrate seamlessly with SCADA, the supervisory control and data acquisition systems, HMI, panels, and then robotic controllers. You can have also centralized control of complex processes and systems, improving efficiency and coordination. Now, these are the hardware components, and then the hardware components, we have the input and output modules, then we have the power supply, we have the processor, which is the central processing unit responsible for executing the logic functions, executing the arithmetic functions, executing the memory functions. Then you also need a programming device, for example, a computer, so that you are able to program this PLC and make it functional. Ladies and gentlemen, let's stop here, and in our next lectures, we will talk more about PLCs, the types of PLCs, and then the different languages used for programming. Thank you so much. See you in the next lecture.